Now we are going to rewrite the first equation with proper notation. We saw that the first equation is written as field F is equal to F in a perturbed universe is equal to F bar in the background universe plus delta F in the plus delta F, which is perturbation in the perturbed universe. So this equation, this expression does not tell us anything about the gauge. So we don't know that this expression refers to what gauge. Now we have defined two perturbed gauges in order to develop the framework for gauge transformation. So in those two perturbed gauges, we will rewrite this expression so that by looking at the equation, it is clear to us that these fields are expressed in, that these field values are in what gauge. So for gauge 1, which is in which the coordinates are expressed, its coordinates are written using the notation x alpha caret. So in gauge 1, we will rewrite this equation as f caret is equal to f bar plus delta f caret, and caret symbol is the notation for the gauge 1. And similarly, we can rewrite this in gauge 2 as f tilde is equal to f bar plus delta f tilde. And notice that I am expressing everything in terms of x alpha. However, you can also replace this x alpha with x alpha caret, where x alpha caret is the coordinates corresponding to x alpha. X alpha caret is the set of coordinates in gauge 1 corresponding to x alpha in the background universe. So x alpha caret and x alpha, they have the same values. X alpha, the points will be different. X alpha caret at point P1 is equal to x alpha at point P, and they both refer to different points, different physical points in the four-dimensional space-time, so that their coordinates, the value of coordinates are equal. For example, let us say that I am choosing a coordinate x alpha is equal to 1, 0, 0, 0. So I can write this expression as f caret 1, 0, 0, 0 is equal to f bar 1 plus delta f caret 1, 0, 0, 0. Now I can also, this 1, 0, 0, 0 is the coordinates of the background universe of a point. They are the coordinates of a point in the background universe. But I can also, the way this framework is constructed, I should be able to visualize this expression at the same set of coordinates in the perturbed universe, which means this coordinates 1, 0, 0, 0 can also be the coordinates of perturbed universe. So I can also write, instead of x alpha caret, where this expression is satisfied, where x alpha caret is equal to x alpha. So f caret x alpha is same as f caret x alpha caret, where x alpha caret is equal to x alpha. But the important point is that when I am enforcing this equality, then I am looking at two different points. Physical location of point P and point P1 will not be the same, because if I keep the physical location same, if I take the same point P, then the coordinates cannot be the same. Therefore, P and P1 are two different points, but those P and P1 points, they are very, very close to each other. But their location is still different location in the four-dimensional space-time. And that different location takes care of this equality. Because if we keep the location same, if P and P1 are at same location, then in two different coordinate systems, they cannot have the same set of coordinates. Now let me, now I decide to write everything in terms of the background universe coordinates. Therefore, I can write in gauge 1 f caret x alpha is equal to f bar eta plus delta f caret x alpha. And in gauge 2, we have f tilde x alpha is equal to f bar eta plus delta f caret plus delta f tilde x alpha. And you may also write where or this will be x alpha tilde where x alpha tilde at some point P2, which is not same as P, the coordinates of x alpha, the coordinates x alpha tilde are equal to the coordinates x alpha at P. So x alpha tilde at some point P2 in the universe, in the four-dimensional space-time, is equal to x alpha at point P. And x alpha tilde is in gauge 2. And they both are equal, so that we can, and by enforcing this equality, we are able to write this x alpha in terms of this x alpha as x alpha tilde. Now, moving further on with our notation, if we have a scalar f, then I will write the equations like this. And if I have a vector field f alpha caret, then instead of putting a caret on f, which I can do, I can either put caret on f and do not put caret on the coordinate, but it's a matter of personal choice. But I decide to, instead of decorating f with caret, I decide to decorate the coordinate with the caret. You can follow either notation. You may decide to decorate f with caret and do not decorate alpha with caret in this case, but I decide to decorate alpha with the caret and not f with caret. So if I have a vector f alpha in gauge 1, I will write equation like this. And if I have a vector f alpha in gauge 2, then the first equation will be written like this. Similarly, I will give you one example for tensor. Consider that tensor field f alpha beta, and in gauge 1, I will write like this. Notice that I am not putting caret on f, but I am putting caret on the indices alpha beta. This should be f bar alpha beta. Should be bar alpha beta. Alpha beta. So we have this and this. This and this is tilde. this also the this field F is F alpha, so we should have F alpha here. So this is the notation that we are going to follow.